All right. So what we're talking about is software security. And we mentioned that with software security, software or the application is where the majority of vulnerabilities are held. Again, this is because, bless you, individuals that are actually developing the code and stuff like that, they are not concerned with the flaws, and the flaws lead to vulnerabilities. So if you're able to get a hold of any source code from any organization, right, you can figure out what the vulnerabilities are, and then you can use that to later exploit. For example, say someone has a particular home router, right? If you have, most people don't change the default configurations nor a patch. You're able to run a tool like Flaw Finder. I don't know what the router may be written in. Find out what the vulnerabilities are, the flaws, and then later prepare a bunch of attacks that will work against that particular appliance. The easiest thing to do. Does anybody remember Stuxnet? Okay, kind of.
Yeah, I've heard of that.
All right, what did you hear?
It was a kind of a platform which they built. So, like, what do I say? I've seen a video of it.
Is that the one where like the US government hired like it was state sponsored stuff? It was
Alleged now.
Oh,
I'm traveling on State Department out alleged.
oh, went into Iran or some Middle Eastern. They were developing a nuclear program and they stopped it with something.
Right.
What?
Yeah, so basically, it was alleged that it was the NSA and that it was the Israeli intelligence group. And together they developed a program that took advantage of the PLCs. That's the programmable logic controller. So in manufacturing, PLCs are important. Like if you can understand how to program PLCs, you can do amazing things with it and secure them. You're good. So Siemens sold the PLC that was used in Iran in their nuclear centrifuge, and so they got a hold of that particular device, learn how to reverse engineering, write malware to that device. And the cool thing about the malware is that the malware went everywhere. It spread everywhere. However, it activated based off location and the configuration. Then the malware it was able to execute. And so what it did was people that were using the actual in the nuclear, doing stuff with the nuclear items, they would see their machines, and the machines would show them that everything was okay. Meanwhile, there was all types of chaos going on in the background, right? So that was huge. Now, the source code for Stuxnet got released. It was put online, and then it was taken down, but the source code was actually released. And so that shows you that if you can get a hold of the particular device that's used in an organization, you can exploit that. You can write something to exploit that device. And understanding the source code allows you to do just that, right? When we ran Flaw Finder against that one application, it took, 10 seconds? And it came up with all those vulnerabilities. It took us to the CWE site, what we needed to fix and stuff like that. What are the problems? You can see right there, this line, this issue, this line, this issue, right? And this is an open source tool. This isn't one that's expensive. This doesn't cost anything. There are much more advanced tools that will give you even more detail. So how many people here can program? You said barely. You need to get your money's worth here.
Well, let's be honest, that's everyone.
Okay. So I say that because, several years ago, I taught in business school, and in terms of programming, it was extremely low, right? It was bad. But with these tools, it even tells an individual who has a lack of programming skills what they need to do to fix the item or exploit, right? So we know about script kiddies, right? So these tools will make someone be like, I don't know if it's like a ransomware kitty, but something very close that they could do those particular things. If you ever go on the dark web and then you try to look up how to make a virus that works with X, Y, and Z, that information will be shown there. Or you just use a VPN, switch your country, and you'll see items that come up, right? So it's not entirely difficult to take advantage of these particular items. And then these particular vulnerabilities, CWEs that came up, these are part of the top 10. Almost 23 years, it's the same stuff over and over and over, right? The same stuff. So when you know how to take advantage of particular exploits and they haven't changed, it's not much you need to do, right? SQL injection. We know the tool, SQL map, run it, boom, you're able to get your stuff. Then from there, you can use a number of other tools to do reconnaissance and then later build up the attacks that you want. These stuff isn't difficult. And these tools make it just so much easier. All right, so here it's talking about requirements. Requirements engineering is a subset of system engineering, right? There's an entire field of people that focused on requirements. That's all they do. They just work on requirements. So here's different assurance requirements. We are going to use the NIST 853. Again, a lot of this stuff is the same. So like I said before, Tuesday, do not get into the nuts and bolts of the stuff at all. Once you understand how one particular CNA or certification accreditation process works, they're all the same, right? It's like if you do a computer science degree or IT degree and an MBA, it's the same as doing a system engineering degree. Has anybody heard of system engineering? Okay, it's the same, right? What's funny is I've been collecting degrees, unfortunately. There's a song that Kanye West has about that, but you begin to realize like a lot of stuff's the same. It's just focus on software, cyber, intelligence, systems. It's the same stuff, same process, or very similar. So with the requirements, federal agencies have their own requirements. So do commercial entities. The Federal Aviation Administration, FAA, they have their own requirements, right? They have their own requirements that are very similar. When you get into very hardcore, I guess, software requirements for security and operating system, those actually come from the FAA. Those are DO 178B requirements or DO 178C now, but those requirements deal with fault trees and stuff like that. There's so much overlap. You'll be shocked. All right. So there's system items here. When I talked earlier this week, I talked about DITSCAP and DICAP. MAC is mission assurance category 1, 2, and 3. And you'll see here that these are the categories of controls: security, design and configuration, personnel, continuity, physical and environment, enclave boundary defense, enclave and computing environment, vulnerability incident management. So these would be like the family requirements. Like personnel could actually deal with the actual requirements for actual people. Do they have clearances? Do they have training? Things of that particular nature. So you would say, all right, this is my system that I'm managing. Do the people that are touching the system meet these requirements? For those that happen to go to the Department of Defense, work for Uncle Sam, our beloved uncle, there's a requirement. The DoD 8570, 8140 means you have a certain certification to even touch a government system. All right, you have to have a certification to even touch the system. Right, you get hired, say, all right, well, within 6 months you have it, or they cut you. Right, that's why I tell everybody get Security Plus. It's the easiest after this class. You should be able to take the Security Plus with your eyes closed. Right, the most difficult one is the CSSP and then CSSLP if you get into engineering. Physical environment, that will deal with where the actual systems are housed, depending on classification, what additional security mechanisms that you need. So with any of these requirements, the ability is to understand which requirements end up being applicable and then which are non-applicable. And then how do you design a system that meets these requirements, right? And then you have budget. They'll say, all right, you have $3 million and you have 50 requirements. Good luck. And you're like, oh crap, I told him I could do this. I really can't. And so you figure out a way to budget those, or build those systems and build those requirements to the system with your budget. And so that becomes the trick. Like the requirements aren't difficult to meet, but it costs to meet each requirement. Example, you may get something that says data at rest needs to be encrypted. You may get a requirement that says you need to have a certain type of encryption for sending data. That device by itself may cost, $50,000 per one appliance. So you're like, oh, I need to encrypt at both endpoints. I'm going to be out in another organization, so I need a device here. I need to pay a personnel to actually manage the crypto keys. I need to design a key management system. And I need to pay for the secure drops. So now you're probably up to like $500,000. Like, oh, only have like a $3 million budget. So you can meet these requirements, but associated with costs. Here, this is ISO 27001. And again, it shows control category and subcategory. So if you look at access control, you'll look down and see business requirement for access control, user access management, user responsibilities, network access control. So just high level, and these are just subcategories. That's all that is. All right, these are just assurance. This is PCI DSS, so payment card industry data security standard. And so you're showing the assessment procedures and the requirements. Every industry has its own requirements, right? So that's why I say if you understand the high level requirements, then you're okay. They'll say, all right, well, you're going to go work in healthcare. Then you will take high trust. That's what they're called, high trust requirements. And you'll take those requirements and further decompose those into requirements that actually can be met within the system. All right, just talk some more about requirements. All right, so there's different life cycles. All these life cycles come from the federal government. Does anybody realize that? Waterfall systems, they all come. Many are from the government. I mean, if you look at the no, there a lot of them come from the government. Yeah, like Waterfall, this is a DoD standard replaced by a military standard. So Department of Defense standard, military standard, modified Waterfall again, MIL standard. And then he has an IEEE. Yeah. So like I worked on a program, it had a spiral method. It was Future Combat Systems, and it was a spiral from the government because it was so expensive to implement. It was like $1 billion government program. Oh, it was insane. It was like the best work I did. First time I ran a Mustang on the government's dime. That was beautiful. But then the government got a hold and said, hey, we're wasting lots of money. And so they did Future Combat Systems was spiral. They had current force, then feature force, then deferred systems. And these were systems that they couldn't afford to actually fund at the moment at that $1 billion budget. And so they did that. And then those that are familiar with, sprints and stuff like that, that's done because a lot of people say, I want a Mercedes-Benz. Okay, great. Come buy it. But I don't have the money for that. I have the money for like a Kia. Oh, okay. So we'll give you a Kia's worth on your Mercedes-Benz. And then you come back, and then when you get funding, we'll build more and more capabilities. And so that's where a lot of that stuff came from. All right. This right here, this is interesting. So classic waterfall is just, you go from one phase to the next. And in reality, you go to one phase, you're like, oh crap, I don't really meet everything in the phase. You go back to the previous phase. That's all that is. Here is just saying that you can take a modified waterfall and mix it with other different projects, right? Because it can be extremely complicated. Like you'll have a system, and then within that system you're designing, you'll have many subsystems. A lot of the systems I worked on, they were mission critical. So, I mean, you're working on like a tank, right? So a tank has many systems on it, believe it or not. We had encryption on the tank. So we had inline network encryptor, INE. So we had a system for encryption. We had a system to communicate with other tanks. We had a tracker to track friendlies. We had all this equipment. So they were all subsystems that were part of the overall system, which was the tank. And so they all had their own, dates for development, release, interoperability testing and stuff. And so everything had like their own different particular cycle for development, and individuals who had to approve stuff, right? So we'd have one agency that would say, all right, you're going to use this inline encryptor. NSA, the NSA would say, all right, well, we need to approve everything you're doing with the system, the hardware, the software. You're going to run our test algorithm, test keys, test algorithms. We had to go through the entire system with the NSA. Then we had another part that we did message testing. So one of the things is when you're in military vehicles, you need to send messages back and forth. So then we had to have another sub-project, which was message testing between other particular tank platforms on the battlefield. And so it gets extremely complicated. That's just a tank, right? So you can imagine you're dealing with much larger and more complex systems.
A plane.
Yeah, so I worked on a plane. Yeah, I worked on a plane called EA6B Block 1 Mod 1. And that plane was interesting. Okay, let me see. Okay, my mouse isn't working the best. Let me see. EA6B Block 1 Mod 1. So if I can pull it over, I'll show you how the plane looks. Okay, that's a Prowler. Oh, EAB. Okay, no wonder it came out like that. Okay, it's not coming up, but it's a tank that flies above a submarine, and it basically deals with like nuclear information, so two-person integrity, two-person control. But the plane, it was so complicated. We had, you remember I told you the different data classifications? So they had SDI data, so it's Intel data. So in the plane, we had to make sure that individuals walking around could not see information. Individuals that were working on certain systems, there are two persons at all time. So it gets extremely complicated. So yeah, the plane was complicated. It depends on the mission. There was another plane, not plane. This is like the dumbest thing ever. LIMV. This is something I worked on right before I came to academia. And I'll show you this. And this was another complicated ordeal. So I worked on this for a while. This is a long endurance multi-intelligence vehicle. So the goal is like if you're in the battlefield, you should be able to communicate with all these different devices below you, UAVs, other rotary wing, fixed wing aircraft, and stuff like that.
So it's like a Blimpie plane?
Well, that people live in.
People live in that?
Yeah, you're up there for, I believe, for I can't remember I do remember the exact time, but you're in there for a while. There's people actually that are in the vehicle.
Is so I guess with something like that, can it like really do anything like in like urgently or anything? Because it just looks like it can it move quickly to like get someone.
You know, sometimes I always say that sometimes the government they want to build things, and it shows how it's supposed to work. So I can communicate to all these different particular items and
Oh, okay. So
yeah.
Okay, so it's meant to kind of like be a little satellite. So
Yeah, or a command center.
okay.
So when I left the program, when I went in academia, this actual the blimp itself got blown away in Pennsylvania. It was a clusterfuck. Oh my gosh.
I'm imagining something like that happening.
Yeah, it was. When I'm not recording, there's some programs out there that you're just wondering like, oh, this is where my tax dollars it goes. Like I worked a program called Transformer with DARPA. It's a flying Humvee, and I was like, you know what? Another cluster, yeah. But I mean, it's tax dollars. I had an expensive condo to pay downtown Baltimore, so I was like, you know what? Whatever. It was a townhome. Yeah, I was like, all right, I'll take your money. I got bills to pay. All right, here's a spiral model right here. Spiral model, rapid application development models. Here it just says iterative, but the spiral cycles are much smaller, risk-based approach, focus on good enough outcome. And then here it just says that the SDLC, the system development lifecycle, software development lifecycle, they still apply, the fundamentals. All right, incremental, so it's incremental. Here's just talking about the need for speed, agile. Anybody here familiar with agile?
Yeah, everywhere.
There's agile, there's scalable, scalable agile, security agile. So agile is interesting. So basically, you're able to put out products fast. And one of the key things about agile, not just fast, but the problem is lack of documentation. Yeah, so you're spitting all types of stuff. It's like, okay, did you do documentation? Did you do appropriate testing? That becomes the reality at the end. Like, okay, you got it done, but it's like, do you want a car that's done agile?
Oh, interesting. Okay.
Yeah, it's like, okay, you gave me
Like a Tesla.
Yeah, well, no, you're not gonna get that with Agile. You're not gonna get that. Here you have Scrum, so basically an Agile development methodology and model that's both iterative and incremental. So you can actually get certifications in these particular models. There's actually the Project Management Institute has the PMI Scrum or Agile, but PMI has a certification for this particular model. So if you actually want to lead these, there's all types of certifications out there. Do I think they're worthwhile? That begs to differ. If you do want to become like an expert in like one of these particular models, I would say go for the higher level fundamentals like the PMI PMP or CAPM if you want to take a test right now. Those would be more beneficial than focusing on like these specialty models. All right. So we're just going to, so this is the MIL standard. This is the system engineering process. There's a book by Fabrici and Blanchard. This book is like for 4 system engineering class at Johns Hopkins University. The same book works for 4 classes. We used to call it the system engineering Bible, but this is the actual system engineering process. When I showed that big chart, I call it the job that leads to the most divorces in America at that time. In the engineering world.
Did they call this one the V model? I feel like
Yeah, it's the V.
The V, yeah.
Yeah, but remember when I showed that DoD process with all those different things happening, this was in there. This was one of these small things in there. Yeah, so being like a program manager, you need to understand how this works and then all the other entities as well. So contracts, subcontract management, financing, well, planning, programming, financing, everything. And so this is just one of the things that the program manager does, at least on a tech side with the government and stuff like that. But yeah, this is the process right here. And it's interesting because this process, understanding, like if you understand the V process, you can get through a lot of stuff. Like a lot of the CNA stuff, you'll just know, okay, I'm going through testing. When do I actually need to do my security testing, the third party sign off? When do I need to actually have my security requirements? Same right here. Okay, security requirements should be right here. So when we're doing the overall system architecture, now I know to add in whatever security items because it will save money in the long run. All right, I wouldn't wait all the way down here towards coding to say, oh, add these security items in here. It makes no sense. All right, here just saying everything must be traceable. You just need to be able to trace everything you do. That's it. There's a software through IBM called DOORS, Dynamic Object Oriented Requirements. I'm not a fan of it, but DOORS, because there's people that do requirements, that's their full job, just to do requirements engineering. And with DOORS, you trace requirements from a high level all the way to a low level to test documents. And then you're able to, it's called the SSDD, System Subsystem Design Document. And that document shows how you're going to test and design everything.
Oh, so it's object oriented, similar to like classes and subclasses.
I'll show an example. Let me show an example. So I went to a course for this. Again, not one of my favorite things. And I lived in Iowa, so when I tell you I did all these courses, I wasn't in the funnest place in America, so it's not like I had much else to do, right? So this is DOORS. So you can see this is how it looks. And you can see like this document, when you in this class, we'll build something similar. But you can see that this document has like, these are WBS items, this is work breakdown schedule, and everything's broken down. You can see how they pretty much have everything either going tracing up or tracing down. And that's what this document does. Yeah, you could say it's pretty detailed. And so in this document, in this particular application, you'll attach items like, okay, I'm looking at the software item. You'll attach the document to the software. You will direct that requirement directly to the CSCI that you're working on, the actual subcomponent software item. It'll be mapped directly there. And then that team will take your requirements and build it in. So the people who usually do this job are system engineers. The running joke is that a system engineer is we call them PowerPoint engineers, right? You do all this great stuff. You create presentations. Oh yeah, this is what we're going to do. We're building this, but you don't do anything, right? You make documents, you draw high level architectural items, and then other engineers actually build it. Huh? Yeah, you get an engineering title. So I had an engineering title as a lead engineer. I did a course in system engineering. I'm certified through the Department of Defense. But yeah, it's a boondoggle. I'll talk when I'm not recording about it, but if you want to move up and make money quick, system engineering architecture is the way to go. Like, you do a job like that, you become a program manager, a director, then a vice president. That is the way to go if you are trying to move up and make money quick in life. On the technical side, it will do wonders for you. Now, will you have some shitty jobs? Yeah, you will. You may be the lead architect and then doing this screwy stuff for like a year or 2 years. Yeah. But in the end, it's worth it. When you check your bank account, you're like, okay, maybe life's not so bad. All right, another process. We're not going to touch this one. This is the IEEE 1220 system life cycle. Again, all these processes, they're like the same. All this right here is just saying that you're going to introduce security into the life cycle. Right? So you have SCR all the way to operational readiness review, and it's showing where you do your security stuff at.
No, does this one start at the top or start at the bottom?
Oh, these are all mapped in together. So you'll be working on a program, and the program, you may have to be compliant to a number of different life cycles. Remember earlier when they showed the waterfall and it showed all the sub projects? Perfect example. But the good thing is, if you are an individual contributor, you're just the engineer or security person, you're just focused on the security parts, right? Now, if you have lofty goals of being a system engineer or technical project manager or a program manager, you are concerned with all of this, right? So it depends on what you want to do and your scope of responsibility. All right, so we're gonna jump here. All right, this is just the issue process. Discover protection needs, define requirements, design security architecture, develop security architecture, detailed architecture, implement security, and then assess security effectiveness. There's also a CMMI model as well for software assurance. And that's a whole nother detailed model that goes through hardcore software assurance requirements, assessments, tests, and stuff like that. All right, so what I'm going to do now is I'm going to skip through. All right, just a few things. So reference monitor, conceptual abstraction of the machine system or software that mediates the access of objects and subjects. Remember, object can't talk directly to a subject. So the reference monitor is the item in between. There's different methodologies, BIBA, Billapodule, and those, and Clark Wilson, those are what dictates how the subject and object can interact. Very high level. Trusted computing base, that is everything together that meets the CIA triad objectives. Security kernel is part of the trusted computing base that implements the reference monitor concept. And then we'll go right here. All right, so here's talking about security kernel, implementation of a reference monitoring mechanism responsible for enforcing security policy. You look right here, this is our lovely ring, right? 0 all the way to 3. And then it meets 3 following conditions: completeness, isolation, verifiability. Again, the security kernel, it needs to be small enough so it can be reviewed appropriately. You can't have something that's too large. And so a lot of your really secure operating systems, they come from aviation. If you look online, there's something called the Karman criteria. You'll see that a lot of those really good trusted operating systems or whatever, real-time operating system, RTOS, they come from aviation. Right? They're like, oh, we built it for aviation, and it meets those needs that that they have there. They'll move those over into security. So the way it works, mission, safety, security, right? Those are kind of the 3 things. That's from a government standpoint, right? Commercial is very different. Yes.
I guess my question is, for it comes for a lot of these stemming from aviation is because they're so mission critical
Mhm.
in that situation that they would spawn.
I mean, you're flying a plane. I mean, you have to make sure it doesn't crash, right? And so you have to be able to verify everything that does. And there's something called fault tree analysis. There's multiple fault tree analysis, but the fault tree analysis in aviation says that this fails, what other component takes over? So imagine you're in a plane, you're with a ton of with a group. I don't know how many people are in fixed wing aircraft, maybe like 100. You have to say, all right, well, this is safe to fly. Like we know that the software is safe to fly. There's even a process for the hardware, DO-254, and that's the process for hardware and aircraft, the commercial process. So they go through a lot of work to make sure that the hardware and software and airplanes will take you to where you need to be. Regardless if you think it or not, you guys might be flying Spirit, but they are still supposed to go through the same stringent requirements if you believe you're going to make it or not. So with those stringent requirements, they get moved over in security. Now, for those that end up, in the military or working for the government, that's why I said mission comes first. They need mission, safety, then security, right? So whatever mission needs and goals, they'll come first. Safety, you have a plane and you can't say, all right, we're going to have these added items of encrypting these messages, but then you can't send the messages to the next aircraft because maybe they don't have the ability to decrypt what you have. There wasn't key exchange or something like that. So that doesn't really work. And then safety, right? Then security comes last. So you just got to figure out like what particular, I guess you can say, sector, whether it's public or private sector, and then where exactly you are going to figure out where you work at or where your system is actually going to be housed at. And that will dictate what's important. All right, ring O is the kernel, one's the OS, then you have utilities and applications. All right, so I'm going to just get through this. We'll cover this a bit more. Here, just talking about different types of controls, social engineering, user awareness training. We'll talk about that because I wrote a paper a couple years ago that talks about hardcore social engineering. So done a number of training and stuff like that to look at how social engineering can actually be done and above and beyond what people are very familiar with. Like actually building trust, taking personality traits and exploiting that. You like certain activities, I like certain activities. You hate certain things, I hate certain things. And all of a sudden I'm building up a way that you just trust me, like you feel like we're friends, like we're soulmates, right? It's like, at most, like it's like the older brother I never had. Really, I'm going to take you for all you got. So I did some research on that, and so talk about that. Talk about it in the future.
I wrote about social engineering for both my TwixStat papers.
Yeah, what?
I wrote about social engineering for my TwixStat papers.
Oh, you did?
Yeah, so I'm curious to read what you've written.
Okay, what do you? Okay. All right, so key here. So programming languages in a nutshell, you have low-level programming languages, assembly. Has anybody written in assembly before?
Oh.
One person. So years ago, I used to teach assembly. I used to teach using NASM and stuff. I'm using it on Linux-based systems. I actually have one of my old lectures still up there. It's probably the only one that has like a lot of views, like over 13,000. But yeah, I used to teach low-level programming because it's important because you can actually write malware to low-level stuff. You can write malware to hardware. Like when they wrote it to the PLC, that's what they're doing. But it's difficult because you really have to understand the hardware that you're writing to. Now, high level, it's like Python, C++, even C, Java, and stuff like that. So I'm going to go through. We don't need DBMS stuff. Not now. That's what I want to get to is this. Here we go. All right. Threat. Okay, here we go. All right. So here, it's talking about a relationship between threat, risk, and countermeasure. So threat source is an entity that may act as a vulnerability, a threat, any potential danger to an information lifecycle. Vulnerability, system has a weakness or a flaw that can provide an opportunity to a threat source. Risk is the likelihood of that occurring. If you have a risk and you usually quantify it, you say, all right, the risk is going to be 85% happening. 85% it's going to happen, right? It is going to happen. So it's like, okay, then you have to execute proper risk management and say, all right, well, I'm either going to accept the risk, I'm going to transfer the risk. Think about different ways to deal with the risk. When we do our project, you will create a file that deals with managing risk. All right, you'll create a whole file that deals with managing risk. Exposure, instance of being compromised by a threat source, and then countermeasure safeguard. What are you going to do to mitigate the potential risk? Now, with some of these components, that makes a document classified actually. So if you have a document, you say, all right, this is the threat, this is what can happen, this is a countermeasure, that document then becomes classified to the highest level of that system. Because you just basically identify the threats, how you can treat it, and then what could actually happen if it's not treated or, protected.
I just thought of like an example, but like you heard like the zombie plan.
What's the zombie plan?
Is an example document to like demonstrate like how the file, the format would be done.
Mhm.
I forget the specific name of the file. It's like basically like a plan to like for a zombie apocalypse basically.
Hmm.
It's basically used like a demonstration like of how the format should be basically. Right.
So I was working on something a while ago, and it was basically called like a zombie attack. So basically, what would happen would be, okay, I guess zombie wouldn't be the right. It would be like if I'm using real monsters like a vampire. So during certain hours, the code would remain dormant, the malicious code, and in certain hours, it would become active. And so that was something like it would know the system's time, and then it would activate and deactivate according to system time and cause havoc and stuff like that. Because a lot of times when you have malware that executes, it's there. You're like, oh, I know it's there because now you have alerts, you can't do certain things. But if it occurs at hours that one should be sleeping, who cares, right? What are you going to be asleep? So that was the whole premise of figuring out like, I guess, smarter malware in terms of like behavior malware and stuff like that, like changing the behavior of malware so it could do what it needs to be done at certain hours and stuff like that, depending upon location and things of that nature. All right, so vulnerabilities are weaknesses that allow attackers to compromise security objectives of systems. Defects, these are flaws or implementation weaknesses. And then bugs are implementation level weaknesses. There's a tool called Find Bugs. We should have enough time to run through it, but Find Bugs basically finds implementation level weaknesses. CWE. So this is what you were seeing. So this is the online dictionary of software weaknesses. And you can see like there's a lot of, the community's big. There are thousands of CWEs out there. Naeem, Ed Bellis was talking about that in terms of the application he built.
Oh.
Yeah. So for those that made it, Ed Bellis, his company, Keenet Security, got acquired by Cisco. And he's doing well. His company is actually looking at dictionaries such as this and ways to address this for organizations that need to be really focused on this. So if you're able to understand like how to navigate the dictionary and stuff like that, you can protect people or you could, take advantage. Depends. Okay, we'll cover that. So insecure interaction between objects, risky resource management, porous defenses, hard-coded passwords. You'd be surprised when people hard code passwords in. I don't know why. Here's talking about how to reduce and eliminate software vulnerabilities, address structural design flaws, develop abuse use cases, design system architecture, understand the actual needs, the infrastructure protection needs. And then for addressing bugs, develop detailed software design and specifications, implement code reviews. Code reviews are not difficult. Code reviews is basically getting in a group, getting in a room, say, hey, here's the code I wrote. Other people look at my code. Is it good code or is it shitty code? That's all it is. It is nothing complicated. That's all a code review is. It's like a powwow. We look at your code. Like, yeah, Mo, this is garbage. I used to code in 8 and 95, and I wrote some garbage code. It worked, but was it garbage? It was. It's like, Mo, this is bad. Like, you should change some things. Like, there's some issues. Because for us, we had we didn't really use static code analyzers or even dynamic code analyzers because they were pricey. So we would have to budget into the actual program. It's like, $20,000. Yeah, we're not going to do that. We're just going to do it ourselves because we're trying to be competitive in bidding for actual projects. Now, later, it was 2010 that the government finally realized that, hey, we have issues with code. And so the first place that did secure coding was Maxwell Air Force Base, and they had a software assurance center of excellence. And so then they actually start putting out a lot of stuff that dealt with secure coding. IC Squared created their first certification in secure coding. Then it was SANS and other organizations followed. But it was not a thing at all. All right, so we don't need to go through all of these. So let's see, do we need to do this? All right, we don't need to do that. Okay, now what we're going to do is we're going to do the exercise. And we are going to get find bugs. Let's see. Okay. So this is all I type. I type sudo apt install find bugs. I'm gonna do yes. Wait. See what I did wrong. It find bugs and I think Java or JavaScript. That's what it does. I think it might. I'll take a look. Take a look in a bit. Let's see what does not work. Sudo apt -get find bugs. Okay, seems like that's working. Let me provide this in the chat.
What was wrong with that?
This right here, sudo space app. Actually, I'll bring this over here.
You want to install find bugs.
Yeah. So find bugs came up. Let's find bugs right there.
Windows is not a big one.
So let me make sure I know which. Let's see, find bugs.
No, it's any Java.
Yeah, I'm looking right now. It says find bugs, including a few security flaws in Java programs, legacy not maintain, use spot bugs or other entry instead. Okay. Huh?
I just thought it works so much.
Yeah, you can actually install find bugs in Eclipse.
Oh, interesting.
You can actually, it can be more static. So actually writing find bugs will come up. All right, so I'm going to do this. I'm gonna give you guys this. I'm gonna download something and I'm gonna just demonstrate. Sweet Home 3D. That's a pretty screwed up program. Download source. So just downloading it right now. Grab this. Let's see something real quick. File. New project. Sweet Home. And remove. That's weird. Okay, let me. Oh, it's SRC. Okay, I'm just trying to. Let me just move this to desktop. That'll be easier. Okay, I'm just trying to locate the files. That's not it. All right, so this is what I'm doing right now. So you can see, just trying to locate exactly where these files are. And then once I'm able to locate these files, actually, I should do this, it'd be easier. Just trying to locate jar files. That's CAR.
If I could have it run on some way for the program and stuff.
Okay, open file location. Ah, okay, it's in tools. That's the one. I'm gonna bring it up. I'm gonna just add more items here. Choose. Library. Jeez. And this is okay, tools J Suite. Okay, I think I know where everything's at now. Remember, you need to attach the jar file and all the good jazz. So be sure to find the actual file. Well, that was perfect. Okay. Oh, thank God that took a lot. Okay. So I was able to find everything. So I've added everything here. I created a new project. I'm gonna hit analyze. We'll see if it works.
Did you look at sample we can use?
I just did.
Yeah, sure.
I just did Sweet Home 3D.
There's like sample, there's a lot of samples for testing various things out there.
Yeah, I would just say go to Sweet Home 3D or Sweet Home 3D or find one that you can pull the files from. And it didn't work. Let me try this again. New project. Right. So I think what I'm going to do now is we're going to download another source code and just analyze that. All right, this may work. I'm using Turbo VNC to see if that works. If it has a GitHub, you can download the items from GitHub. Doesn't matter, as long as you can get the source code.
Do the plugins allow you to either find different types of bugs or work with different types of programs?
The plugins for find bugs.
Or find bugs?
Where are these plugins at?
Oh, I just looked I went down the menu and saw I could add a plugin somewhere.
Yeah, there is a plugin that's, it's like.
Preferences? Preferences, yeah.
I'm just waiting for Turbo VNC to download. So once it's downloaded, I will run this one.
Oh, wait, no.
So let me know if it works. Otherwise, it may mean that and it may need to update, change the Java version.
How do we tell it the Java file we'd like to test?
You need to go in there and search for where the Java file is. So once you extract it, go in there and then type in .jar, right click on the file, open item location, and then use that to figure out where the other files are at. The Lord, how's this file still downloading?
New project or
Oh, it did download. Okay. So let's try this one. New project, Turbo. And Here's triple DNC.
IO exceptional scanning code basis. This one I click on. The IO exception.
Yeah, I got it as well.
IO
So
exception.
let me see something. Why is that making? It shouldn't be working like that. Okay.
Take the job done, right?
Yeah, any of the other files, Java, WAR, EAR, zip, it should be able to take any of those. Files are at. That's JR. Okay. So network. Java.com. That one's not working. Still getting the exception, the error.
It's happening with me, troubleshooting and various password might be an open issue.
So I'm gonna try something else. Looking right now. I can search Forge. All right, so I'm going back in here. So I'm going to try another program real quick. It should work. So what I have to do is I have to figure out why this is causing issues, because it shouldn't cause any issues. But again, there's always items that come up. Download yet? Almost like 10 seconds. Extract. Okay. All right. What is this? Oh, that's even better. Okay. Week at 9.6. Okay, so I see it. I'm getting the same error, so there must be something with the application. So let me see something.
I was just trying to get around that. The first forum I saw for it rerouted me to another forum, which that was still open. So.
I found that it says find bugs is abandoned.
Yeah, it should still work though. Let's see, let me just add this. And okay. Let's see. All right, so we just have to use something else in the meantime. There's a ton of other programs. Hoping that this will work. What I'm going to do is I'm going to get this working so you guys can see how this works. Yeah, so even if a program's abandoned, the code is still there, so it should be able to work.
Right.
Yeah.
Get that. I'm thinking how recent though is the program we're trying to analyze, because if it's like a newer version of Java, it might have like stuff that
Let's see, find bug Java. So what I'm looking now is a find bugs Java requirement. Find bugs. University of Maryland. I think that's the university here that created this application. Because it may just have to install it directly from the university webpage, and that's what I'm looking at right now. Okay, I think that's what I'm gonna do real quick. Let me remove find bugs, sudo apt auto remove and purge find bugs. This. So I'm going to try this. Like I said, there's always workarounds. I don't think we have another class. Do we have another class after this? Does anybody else try to come in after here? Do you know? Okay. This Wi-Fi is pretty bad. Does anybody else have slow Wi-Fi?
Oh, no different than regular.
Oh,
Maybe just.
usually mine's is decent, but I'm like, it should not take forever for these items to download. It's like it's just, I feel like it's moving super slow. Okay, let me navigate here. CD download. Where is do all right, so I have this. All right, I will let you know if this works in a little bit. Okay, so I have an older version of Find Bugs installed. And we'll see if this actually works. Well, not older version, straight from the university's page. This works. We are in business. Let's see. Good Lord. Let's see if this works. That's there. That's there. Motherfucker. I mean, sorry. I'm excited. It is working. That was inner excitement, people. Whew, good Lord. Okay. All right, so you have to go to the find bugs. You can't just do the sudo apt install find bugs. You have to go to the main page, University of Maryland. I will give you the link right now. And you too will be destined for greatness. So I went into the bin folder, and in the bin folder, I did sudo space sh find bugs, enter, it executes the executable file, and then it runs. And that is how you get it to run here. So apologies, I thought that was going to be the easiest way when I went through the sudo app install. I guess it isn't. But it seems like this is working because this how it should look when it's running. I feel like I accomplished something today. I can actually go home, forget my other class. All right, any questions while we wrap up? Good. Look, you're ready to run. You got your jacket on and
I do.
oh yeah, it's done. It's gonna run. It might take like 5 minutes, but I'm just gonna record. So when I do post this video, you guys will see it. So if you gotta run, you can run, but it's working. That's another tool. You got how it runs. What will happen on the left right here? All the bugs will populate. It won't tell you the CWE or CVE, but it will tell you exactly what's wrong. And you just search it up on there, and it pretty much matches as best as possible. But yeah, you can see this one has taken a while, which means there'll probably be like a couple hundred at least.
Like the project, like your project, like whoever runs the code, like, and whoever has to pull the CWE, they would just look at like on the left side. And then, oh, okay.
Yeah, and then if you have money, you can pay for the cloud. And the cloud version will do a lot better mapping rather than manually doing it. So I would recommend, like, you know, if you're working at an organization, I would make them spend the extra money. I mean, it makes your job easier. But there's some really cool tools. I need to send out the papers that I published with some students, grad students from Spain and France. I think one was from France. They actually did a project using a tool that actually cost quite a bit of money. And you can see the big difference. Analyze here.
Ooh, 3,700.
Yeah. Yep, and you can see, voila, there it is. Yeah, it's a crap ton. And then you can, you know, change category, bug kind, bug pattern, the actual level. That's pretty detailed. All right. So next week, will we meet in class at all? Nope. But
Oh, that's right.
yeah,
Thank you.
I will see you guys. Sorry? Yeah, and I might have to record and post it for you guys to view. And then I'll be back the next week. Sorry? Yeah.
Thank you.
All right, I'll see you guys. Be safe. Enjoy your weekend.
Thank you. Have a good day.
Really, I didn't have that on the